In the PRiME project, we have used a formal mathematical language called Event B, together with a supporting tool called Rodin, to model and verify the runtime management software systems of multi-core systems. We wanted to create a public engagement activity in order to engage children with the ideas behind Rodin Maths. We did this by creating two simple case studies, safe driving and safe landing. The first event we took part in was the Southampton Science and Engineering Day, part of the British Science Week, held at the University of Southampton in March 2016. This day has a total of about 6,000 visitors, mostly primary school students. We were very pleased that around 200 students completed our activity and learned about using maths to ensure safety in a parking case study. The second event was the Farnborough International Air Show held in August 2016 with a different range of visitors' ages. This time, around 30 students engaged in the activity in more detail and explored the concept of mathematical modeling of a safe airplane landing system. One of our challenges was satisfying different mathematical abilities from young children to older teenagers. Here I'll show an overview of the air show activity. However, the other case study was similar. The activity involved 3 steps. First, children were provided with instruction sheets for the case study. We used cartoon characters to encourage younger children to participate. Geraldine and Philippe are 2 pilots who want to land and park at the airport. The children were asked to think about the safety conditions a pilot needs to consider before landing. For example, when Geraldine wants to land and park in space 1, she needs to check whether Philippe is on the runway or whether light 1 is green, indicating that the parking space 1 is free. Without these safety conditions, an accident can happen. The second step is where the children have the opportunity to play with the graphical visualization of the mathematical model in the Rodin tool and validate their thoughts from the first step by choosing the safety conditions in a specific scenario. If the safety conditions were selected correctly, the model would not allow the second plane to be moved to an occupied space. Alternatively, if we clear the selection, then an accident could happen. We also use the Venn diagram to demonstrate the logical sets of the spaces. An example of safety condition here is that the counting within a set must not be more than 1. 2 or more indicates an accident. For those participants interested in a further level of engagement, the mathematical model, including the variables specifying the system space and events specifying the system actions, were demonstrated. And a detailed engagement was demonstration of the mathematical proofs generated and proved by the tool to ensure the safety conditions. We asked participants to give feedback on the activity. The results showed almost equal participation of girls and boys. It also showed that 79% of participants found the activity interesting, and almost 100% said they learned about safety and how to use mathematics to make sure systems are safe. In summary, in the PRiME project, we are interested in engaging the public with our ongoing research. Southampton Science and Engineering Day and the Farnborough Air Show were 2 successful examples of this, and we envisage expanding our public engagement activities in the future.